Welcome to the fascinating world of organic chemistry, a branch of science that explores the structure, properties, and reactions of compounds containing carbon. In ICSE Class 10, organic chemistry forms a crucial part of your syllabus, laying the foundation for advanced studies. This video will guide you through the essential concepts, from the basics of carbon compounds to their various reactions and uses in daily life. Let's embark on this journey to understand why organic chemistry is often called the chemistry of life and how it connects to everything from fuels to medicines. Get ready to unravel the mysteries of carbon-based compounds. Organic compounds are molecules primarily made up of carbon and hydrogen, often with other elements like oxygen, nitrogen, and sulfur. These compounds are the building blocks of all living things, from plants and animals to humans. In this scene, we'll discuss what makes a compound organic and why carbon is so special. Its ability to form 4 covalent bonds allows for a vast variety of structures, making organic chemistry incredibly diverse. Understanding these basics is key to mastering the subject and appreciating its relevance in everyday life. Carbon's unique ability to form long chains and rings, known as catenation, sets it apart from other elements. This property allows carbon atoms to bond with each other in countless ways, creating a huge variety of organic molecules. Additionally, carbon can form single, double, or triple bonds, further increasing the diversity of organic compounds. This versatility is the reason why organic chemistry is such a vast and important field. Let's explore how these properties lead to the formation of different types of organic compounds. Organic compounds can be classified into 2 broad categories: open-chain aliphatic and closed-chain cyclic compounds. Open-chain compounds have straight or branched chains of carbon atoms, while closed-chain compounds form rings. Further, they can be saturated single bonds only or unsaturated double or triple bonds present. Understanding this classification helps in identifying and naming organic compounds, which is a fundamental skill in organic chemistry. Homologous series is a group of organic compounds with similar structures and chemical properties, differing by CH2 unit. For example, alkanes like methane, ethane, and propane belong to the same homologous series. Each member has a similar general formula and shows a gradual change in physical properties, such as boiling point. Recognizing homologous series helps in predicting the properties and reactions of organic compounds, making it easier to study them systematically. Alkanes are the simplest type of hydrocarbons, containing only single bonds between carbon atoms. Their general formula is CnH2n+2. Common examples include methane, ethane, and propane. Alkanes are saturated compounds, meaning all carbon atoms are bonded to the maximum number of hydrogen atoms. They are generally unreactive but can undergo combustion to produce energy. Understanding alkanes is the first step in exploring the world of hydrocarbon. Alkenes and alkynes are unsaturated hydrocarbons. Alkenes contain at least one double bond between carbon atoms, with the general formula CnH2n. Alkynes have at least one triple bond, with the formula CnH2n2. These compounds are more reactive than alkanes due to the presence of multiple bonds. Ethene and ethine are the simplest examples of alkenes and alkynes, respectively. Their reactivity makes them important in various chemical industries. Functional groups are specific groups of atoms within molecules that determine the chemical properties of those molecules. Common functional groups include alcohols, OH, aldehyde CHO, ketones C=O, carboxylic acid COH, and more. Recognizing functional groups is essential for identifying organic compounds and predicting their reactions. They are the key to understanding the behavior of organic molecules in different chemical reactions. Naming organic compounds follows a set of rules established by IUPAC. The name reflects the structure, including the length of the carbon chain, the type of bonds, and the presence of functional groups. For example, ethanol indicates a 2-carbon chain with an alcohol group. Mastering nomenclature helps in communicating chemical information clearly and accurately, which is vital for exams and further studies. Isomerism refers to the phenomenon where compounds have the same molecular formula but different structures or arrangements of atoms. Structural isomers differ in the connectivity of atoms, while stereoisomers differ in spatial arrangement. Isomerism explains why 2 substances with the same formula can have very different properties. Understanding isomerism is crucial for solving problems and predicting the behavior of organic compounds. Organic compounds are found in nature and can also be synthesized in laboratories. Natural sources include plants, animals, and fossil fuels like petroleum and coal. Synthetic organic compounds are made through chemical reactions in the lab and are used in products like plastics, medicines, and dyes. Understanding the sources of organic compounds helps us appreciate their importance in our daily lives and the environment. Ethane, the simplest alkane, can be prepared in the laboratory by heating a mixture of sodium acetate and soda lime. This reaction produces methane gas, which can be collected and studied. Methane is a major component of natural gas and is widely used as a fuel. Understanding its preparation and properties is a key part of the ICSE syllabus. Ethane is a colorless, odorless gas that burns with a blue flame, producing carbon dioxide and water. It is less dense than air and is slightly soluble in water. Methane is non-toxic but can be dangerous in confined spaces due to its flammability. Its properties make it an important fuel for heating and electricity generation. Methane is widely used as a domestic and industrial fuel. It is the main component of natural gas used for cooking, heating, and generating electricity. Methane is also a starting material for producing chemicals like hydrogen and methanol. Its clean-burning nature makes it a preferred fuel in many applications. Ethene, the simplest alkene, can be prepared in the laboratory by dehydrating ethanol using concentrated sulfuric acid. The gas produced is collected over water. Ethene is a colorless gas with a sweet smell and is highly reactive due to its double bond. It is an important raw material in the chemical industry. Ethene is a colorless flammable gas with a faint sweet odor. It is less dense than air and is slightly soluble in water. Ethene is highly reactive, especially in addition reactions, making it valuable in the production of plastics and other chemicals. Its properties make it a key compound in organic chemistry. Ethene is used extensively in the chemical industry, especially for making polyethylene, one of the most common plastics. It is also used in the manufacture of ethanol and as a plant hormone to ripen fruits. Its versatility makes ethene a compound of great industrial and agricultural importance. Addition reactions are characteristic of unsaturated hydrocarbons like alkenes and alkynes. In these reactions, atoms or groups are added to the carbon atoms involved in double or triple bonds. For example, ethene reacts with hydrogen to form ethane. Understanding addition reactions is crucial for predicting the behavior of unsaturated organic compounds. Substitution reactions are typical of saturated hydrocarbons like alkanes. In these reactions, one atom or group in a molecule is replaced by another. For example, methane reacts with chlorine in the presence of sunlight to form chloromethane. Substitution reactions are important in the synthesis of many useful organic compounds. Combustion is a chemical reaction where hydrocarbons burn in the presence of oxygen to produce carbon dioxide, water, and energy. Complete combustion gives a blue flame and releases maximum energy, while incomplete combustion produces soot and carbon monoxide. Combustion reactions are the basis for using hydrocarbons as fuels in daily life. We've covered the essential topics of organic chemistry for ICSE Class 10, from the unique properties of carbon to the classification, nomenclature, and reactions of organic compounds. Understanding these basics will help you tackle exam questions with confidence and appreciate the role of organic chemistry in everyday life. Remember, practice is key to mastering the subject. Keep exploring and you'll find organic chemistry both interesting and rewarding.